I'm going to talk to you a bit about Grocon's current BIM project, and then a bit of a construction status on the VCCC in Melbourne here, and then some ways of how we're using BIM for construction on the VCCC. As you just heard, one Blythe Street is where it all began for Grocon. This is also a project that's using BIM at the moment. This is 5 Martin Place in Sydney. 480 Queen Street in Brisbane, Box Hill here in Melbourne. The guys are using Vico to do some 4D and 5D, and using BIMX for iPad use on site. Another project in Melbourne here, 150 Collins Street, Melbourne, and then the VCCC, which I'm going to talk to you about now. So. I'm going to show you an animation now, just going through the VCCC project. So this is a $1 billion hospital project. It's a purpose-built hospital for cancer research, treatment and care here in Melbourne. It's situated at the top of Elizabeth Street, just at the start of Flemington Road. Is designed to resemble the organs of a body, a human body. Animation is prepared for the bid stage of the project. It's a joint venture. It's a joint venture between Grocon and PCL. PCL is a Canadian contractor who's built many hospitals over in Canada, and Planning is the sponsor on the project. The building is 6 floors down and 14 floors up. It's the lecture theatre. Okay. So there's some statistics of the project. 160 overnight inpatient cancer beds, 42 bed capacity intensive care unit, and then over 25,000 square meters of specialized research space. Some statistics of the site, as I mentioned, 6 floors down, 14 floors up, and the main facility is over 100,000 meters squared. We excavated 160,000 meters cubed of earth, and I'm going to show you how we used BIM to help that process, and over 60,000 meters cubed of concrete. As you can see, pretty complicated building envelope. So this is where we are now. You may have seen this as you're driving by Flemington Road. We're planning to finish structure at the end of October, and then we'll be watertight April 2015, and then December 2015 will be finished our commissioning, technical completion February 2016, and then ready to go June 2016. BIM and how it's built, just to show you that we're not just using BIM for design coordination. We're actually modelling all our temporary plant and equipment to help us build the project. We're modelling all the equipment inside the building, so that'll be done by the architect, Siva Thomas Hanley and Design Inc. And also the facade is modelled by MCR. They're using Revit and Rhino. We also have a lot of facade contractors. Structure as well is modelled by Bonacci and also by a trade contractor, Stilcon, who's using Tekla. We model all our own formwork, and we use this for extracting materials and using that data for costings and working out how we can reuse formwork on each level. We also model our own screens. We use our own screens on site, so that's done all in-house. We work out our crane loadings and radiuses using Revit. We also modelled our FRP, GRC, and the precast concrete was modelled in Revit and then was modelled in Tekla. So this is where you begin most projects, build an implementation plan. I just wanted to make sure that everyone makes it their business to include this in everyone's contract at the beginning of a project, even with a small subcontractor that's going to be doing some modelling on your project. Just ensure that this is done at the very beginning and make sure it's all agreed. So this is just a kind of an idea of how things work on the VCCC. As I mentioned, Siva Thomas Hanley and Design Inc. are the architects. Bonacci are doing the structure, all using Revit. And then LCI services, which is Lear, Wood and Grieve, and SPP. Mainly doing their drawings in 2D, and then that data is then passed on to all the subcontractors who do all the modelling of all the services. LCI also modelled some of the plant rooms and the roof services, but the main modelling is done by all the subcontractors. So D&E are doing the mechanical, electrical, Downer is doing the electrical, CBS hydraulics, Fire by Entire, Med Gas doing, or so Hoslab doing the Med Gas, and PET, Comms and ICT all using Revit. And then our facade contractors, Permis de Lisa, using Revit, Bianco, Tekla, Stilcon, Tekla, and Molcam, Rhino. So we used all this data to work out our concrete profile drawings, crane layouts, excavation drawings, etc. And then Navisworks to do all our clash detection and sequencing using Primavera. So Aconex is what we use for data storage and management. We've got over 200 Revit models in this project, so it's a bit of a beast. And these models are transferred every Tuesday and Friday of every week, so a lot of data moving around. Services, as you know, in hospitals, they're pretty packed full of services, and this is no different to any other hospital. It gives you an idea of the work that the subcontractors are doing on this project. As I mentioned, these are some of the guys that are working on the project, and an image of the work that they're doing. I'm just going to give you a quick animation of one of the floors, just to give you an idea of how things come together. First to go in, speed panels, firewalls, smoke and primary acoustic walls, and then the services come along in sequence. We broke this further down into 3 more zones later on, just to give you a better idea of the sequence of each floor. Drainage, mechanical services by D&E. Gas. So as you can see, it's pretty packed. That's just one floor of the building, so we have 20 of those. So yeah, we just do all the usual stuff as well: clash detection, clash with structure, architecture, and also clashes with temporary plant and equipment. So we're using Navisworks to do all our clash detection each week. Prefabrication, D&E are using Revit to do their modelling, and they're also doing some prefabrication. They're making all their risers off-site. So you can see this one here is being constructed on the ground. It's pretty big. So these go up to 20 stories of the building, dropped in by crane. Plant rooms also modelled by D&E and manufactured off-site. So they actually take our formwork tables to their warehouse and then fit the services in underneath the tables. This is then brought to site and we pour the concrete on it, and it's working very well. Also using a Trimble to locate the hangars, as we mentioned earlier on in one of the previous presentations. This just shows you a typical level. Also, BIM 360 glue is widely used in this project. We've got over 50 iPads being used on the project. It's gone pretty well. Autodesk worked with us to get this up and running. Because it's such a big project and such big files, we had a bit of trouble getting everything down to a usable size, but we have it done now. We've got a level-by-level services model on the iPads. We've got a level-by-level facade models, some construction models, etc. So these are some of the key features of using 360 glue, clash detection, markups in the field, activity reporting, and then you've got access anywhere. It's working well. This is a setup that you'll see on our iPads when you open it up. So as I said, structure, models, services, fit out, facade model, just about squeezed it on there, and some construction models as well. This is a typical layout of a services model. So we have our speed panels, we have our fire smoke walls, acoustic rated walls, all color coordinated, and then all the services color coordinated as well. It's just some images I took on Tuesday. I was asked to go out and do an audit of level 2. The model is the one on the right. You can see it's pretty close. It's hard to find any differences between those images and the images from 360 glue. If you look really hard, you might see some, but they're very, very, very hard to find. It's a credit to all the subcontractors in this project. They're doing an outstanding job. Everyone's taking it on board. All are doing in-house modelling. No one's outsourcing anything. Some of the guys hadn't done this before, so it's working really, really well. The coordination is brilliant so far. Very, very little services have been taken down. Just some more images of the corridors. You can see as well how packed these corridors are with services. There's no room at all to move. Just some more images there again. It's hard to find it. As I said, the differences, even the little kinks in the ductwork, everything is as the model was done. Everyone knows where they are, what's going to come ahead of them. If there's an issue on site, we can immediately take out 360 glue and we can see who's in the wrong straight away. There's no arguments. I'm going to just move into some 4D modelling. So here's some advantages of 4D modelling, but in a nutshell, it's so people can visualize the program. It's not just a piece of paper anymore. People want to see it animated, and they want to be able to use it on site. So we use Primavera P6 on VCCC. That's used by the planners. And then what we do is we add a shared parameter to Revit, and then we create search sets in Navisworks. We name the search sets in Navisworks the same as the task in Primavera, so that we can use the auto link tool in Navisworks. Saves a lot of time if you want to be doing that. I just might be able to show you a few more. Yeah, so excavation. So in the early days we used 4D to work out how we're going to excavate the site. As I mentioned, 6 floors down. So we used the modelling to work out how much earth was going to be taken out of the site each week, compact and bulk earth. So it's going to show you. We also worked out where the ramps are going to be, where the access was going to be, where the main soil was going to be, where the final ramp is going to be, and so it gives the ideas. It gives the idea to the excavators what work they're going to be doing. Delta was working on this with me at the beginning of the project. So you get an idea there of how we excavated the site. That's the final bit of work there at the top of the site. So another way we used BIM is for, we did a 4D of a road closure. You can see it looks something similar to this. It's not completely closed. This is Grattan Street. So we will be closing it shortly at night time. And this was used to show the hospital and the council how it's going to go. I'm just going to show you some structure sequencing as well to show you how we're using 4D. I'm going to show you this is the construction of the bunkers which we did on B1 level. I think they were the first radiation bunkers to be suspended. Most people build them either down the bottom of the basement or on the ground because they're such huge structures. So start date is when the columns come in light grey, and then as things get solid, that's when the finish date is. This was done over and over and over again, so we figured out exactly how we were going to build the structure. It was pretty complicated. So this is shown not just to the managers, but this is shown to the guys who are actually working on site. And then we've taken their comments, we redo it. We've taken their comments again, we redo it. It's not just a presentation; it's actually used on site. You can put the native Navisworks file onto a tablet computer, and you can bring it to site. You can stop it on any day you want. You can show people where they are, where they're supposed to be. A planner can walk on the site and stop it and look around and immediately know what's behind and what's ahead. You can see the steel going in between the walls as well. Some of these walls are 1.5 meters wide, and some of the floors are 2 meters thick. They also have steel within them. So we used prefabricated Rio for this, and the typical formwork tables. You can see you can't just build it at one end and then finish up the far end. You have to do it in a particular sequence with the concrete. And you can see the steel going in the roof as well. Steel in the roof, steel in the walls, and steel in the floors. It's a massive structure. Same amount of concrete went into these 9 bunkers as does a 20-story apartment block. That's pretty much it. So I think it took us 90 days to do it in the end. And then I'm just going to show you a final 4D construction simulation that we used for structure and facade. So this is back in September 2012 where we started construction after excavating the full site. So this is used to work out our crane jumps, the jumps in the core, how we're going to break up the slabs, break up the pour breaks in the building. Grocon used the Rebecca jump form as well to jump the cores. And you see the core on the left hand side here, it jumps with the core. The crane side jumps with the core. So you can see we model all our formwork tables and all the floors. It's not as flashy as the Turner 4D. This is taken straight out of the Navisworks model. As I mentioned, this can be brought on site and you can stop it on a particular day. Check out who's ahead, who's behind. So you can see the screens going up in the background there. just come up to where we are now. So you can see the screens move up and the facade follows straight behind it. So we're nearly there. Just have to finish the fit out of the services. So that's watertight now. It looks like it's finished from the outside, but it's a long way from being finished when it's watertight. That's pretty much it. Some lessons learned, timely early adoption in the project. Make sure, as I said, the BIM plan is in everyone's contract before they start. Give people lots of training. Make sure you've got the right equipment, and make sure you've got the right software to do the work that you need to do. Thank you.